as IEEE Day 2019 Winnipeg, Canada section ambassador in University, Manitoba. He evaluated by IEEE admission and advanced committee to grade of IEEE senior member in November 2020. He cooperated with telecommunication students for researching about network quality measuring by new methods. He is also working with Path Publishing as technical reviewer for 5G technology books. He started membership with IEEE since 2006 until now and joined to IEEE Communication of Society, technical community on IEEE Computer Society, computational life science and future network communities. Now I wish to now I wish Payal Alvijade sir to speak a few words about this. Sir.
Thank you so much for introducing me, and thank you for all people, all guys here, and especially thanks for all IEEE members organized this meeting for us. Thank you so much, and I'm ready to start. If you, yeah, I'm ready to start. If you want, yes, thank you.
Hello, sir. Just share a few experience with us, sir.
Sorry, excuse me, I didn't hear you. Sorry. Hello, can you hear me right now?
Yes, sir.
Yes, sir.
Okay, okay. When you are ready, I am ready for a start for talking about wireless communication.
Yes, sir. We are all ready.
Okay, thank you. Okay, thank you again for all attending this meeting. I really appreciate. I'm so excited. Actually, I'm here and talk with you. And actually, I'm excited to see a lot of young people. I think more than 60, I think 67 people in this meeting, and really appreciate for attending to this meeting. So actually, thank you for introducing me. I want to share my experience about wireless communication, and anyone to actually interested to work in this industry after this meeting. I promise to your colleagues about speak about just on talk about friendly talking about the opportunity, which opportunity in the telecommunication sector for a graduate student can work in this area. And I think with the advanced 5G and 6G, we have a lot of opportunity all around the world for working with the new technology. Actually, today I want to talk about wireless communication, and so after that, about the 6G use cases, challenges, and after that we can talk about career opportunities in that in this section. So if you are ready, I want to share my screen about the for presentation. Please let me share my
Hello, sir. You can share your screens.
yes, please let me share my screen, and after that, can you see my screen? Can you see my screen right now? Sorry.
Yes, sir. Your screen is visible.
Okay. So actually, actually for 6G, you know, we are in the start, and the researcher and scientists actually try to finding a best actually the structure and standards for launching in 6G in 2013. The 3GPP actually works hard for providing this the standardization about the 6G. So please let me explain about evolution, cellular network evolution. As you can see here, as you know, somebody remember that these days, somebody, yes, didn't remember actually about that, the oldest generation. In that, actually, if you can see in 1918, you can see we actually started with 1G, just only for voice service with on the FDMA services, and there is no any ability just only for connected to the network and two people call together just only for voice, very limited. And so for 2G in 1919, as you can see, the services provided voice and message services using TDMA and FDMA. You can see, I think you remember this handset for 2G. For 3G, you launched in 2000. You can see in this picture, inter-browsing and web application using WCDMA for providing these services happen. And for 4G right now, I think in your country, you are using for 4G and actually and 5G. Am I right or not started for 5G yet? Uh, Hello? Sorry, can you hear me?
Yes, sir, you can hear.
Yeah, I asked a question. Are you launching 5G in India? Yes, the 5G already run in India. Yes?
Yes,
Are you
sir.
sir class?
Partially, I think partially, some country partially launched 5G for subscribers. So I think in India, I think launched, but I don't know which region right now available and you can use it or not. But in 2020, launch in some countries and expanding the coverage for 5G right now, and all operators, like as in Canada, the operators work hardly for 5G, expanding the 5G and 5G advance. And so the main problem is right now is for operator is the handset, because the subscriber maybe cannot using the 5G handset. And so this is the biggest problem for some countries, maybe has a 5G equipment, but doesn't have enough user equipment for using the 5G. So right now we are in 5G technology, and we can use a complex system, AR, VR, with high speed actually connection available right now, and increase actually based on my experience. I am working right now on the quality of network. We are hard working on the actually the quality section for improving the internet speed and the throughput, especially work on the actually some new features for enable better services for subscriber. And as you can see, in 2013, we expected we have a shift to 6G for enhanced reliable for some services, AI, blockchain, ERLC, and EURLLC, and we can discuss about it in next slides. So this is the 3GPP timeline of 5G and beyond 5G and 6G. As you can see in this picture, you can see that in this area, the traffic vision technology, KPI, and from 2012 started to gathering information about all of these one. And for the 3GPP is organization and released a standardization for wireless communication based on the each year or each quarter, maybe release the new standard for wireless communication. In 2015, release 13, and after that 14, and right now we are in release 18. In release 18, we actually a lot of actually services available for 5G, for actually for using better services of 5G. And release 19 and release 20 in the next year maybe happen. And as you can see in this area, the traffic vision technology starts based on the new IMT version. Right now, we are using this IMT based on the ITU published. The minimum requirement for 5G for starting for 5G release in this one. For 2020, after this, actually, all of this is completed. For traffic, vision, technology, KPI, proposal, specification, all of these gather and completed and work in release. You can see that the same color in release 21 to release 23, all of this completed here. And then we can expect it 6G happen. Sorry. Okay. And so about the 5G advance. About the 5G advance, as you can see, each release of the 3GPP has a lot of provided a lot of services here. And so for release 18 plus, we expected to 5G advance happen for 18 plus. We are using 17, and some vendors move to 18, release 18. And so what happened for 5G advance? The 5G advance actually the reduced capacity happening. What does mean reducing capacity? Uh, for example, I can one example for reduced capacity happen in 5G advance. What happened? Uh, for example, some tiny IoT devices, for example, wearable clothes, equipped with the tiny IoT devices, should be communicate with this network. And the best scenario for connecting to all small IoT to connect to network should be designed and planned based on the bandwidth they need. And they don't want to providing more bandwidth for some tiny or small IoT devices. And so this is why we use to new feature for reducing capacity, for saving more power, saving more capacity for another slice of the network. And so this is why we want to consider for reducing capacity in 5G advance. And another thing, accurating timing, improve the positioning. For example, for improving the positioning, it's very important because for example, you suppose you are in the shopping mall and you want by your mobile, you want to find your position in your, for example, in the mall. And due to you cannot access to GPS, and the position of your handset in actually in the mall maybe is not accurate. By the new services in the 5G Advanced, you can access to, for example, exit actually 10 centimeter actually for accuracy for positioning, and you can use actually between the shelf of the, for example, estimate in the shopping center, you can move and you can see in your mobile your position. And so yes, and for another things about the 5G advance happen, 5G advance using AI. And using AI is the main subject in 5G Advanced and 6G. And I can explain if we have a next meeting, I can more explain about what's the role of AI in 5G Advanced or 6G and what we can do by the AI. Uh, for a spectrum, what happened for actually for a spectrum for 4G, 5G, and 6G? I want to know about that all of technology spectrum using for spectrum frequency, and I want to see the what happened during the generation. In 4G, as you can see, in the 4G, we can use the 1 gigahertz till 3 and until 6 gigahertz as a low band or a subband. We can use this area for 4G. 5G spectrum include all of these frequency, and also we can use millimeter wave, it's actually millimeter wave frequency. And millimeter wave is 24 gigahertz and upper to 100 gigahertz. You can see the 5G working. Okay, what's a benefit of the using of millimeter wave? Millimeter wave means a wave with very actually a high energy, but high energy means actually the less coverage. Uh, but why we should use millimeter wave in 5G and for example and 6G? Why? Actually, 5G Advanced, sorry, about 5G Advanced, because actually we need to communicate with IoT devices. The IoT devices needs to, for example, needs to communicate in the short range of the network. And due to we have a lot of million devices, maybe in network, we try to connect the network, connect to devices by the millimeter wave with the higher energy, and can provide better throughput for all of the devices connected to network. This is just only for dense area in the city. It's not used for rural and road, and just only for actually the dense area, for example, in this the downtown or a special building, and with a lot of IoT devices. And for a spectrum for 6G, what happened for 6G? For 6G, we expected for 100 gigahertz to actually actually for terahertz, 800 terahertz. And this is the actually, as you can see, this is the visible light. This is the area. And so by the actually, this frequency is not regulated right now, and not actually, I believe there is no the country regulatory in a country and regulated the terahertz for cellular mobile communication. We actually use the terahertz in the satellites before that, but for cellular communication right now, actually we didn't use until now. So this is the actually the spectrum vision about the from 4G to 6G. Sorry. Okay, and what's the 6G requirements? The 6G requirements is very important because each technology want to start it should be defined before that define the KPIs and shows the actually the target with on what we can do in network by the KPI we can actually defining the KPI we can achieve the maximum services from the next generation in 6G as you can see the red area, this area is 5G. In this area is 5G, and each actually each point arrow shows the KPIs. As you can see, the 6G is very better than 5G for all parameters. For example, very low latency communication, very low latency. The latency, you can see here, latency, yes, latency is very low from 1 to 0.1. And this is the latency is very important because, you know, for communicating, for example, you suppose a doctor has a surgery from another country and want to use robots for surgery, and the latency has a very at this case is very important for each for this surgery. In 6G, we expected very low latency, and then we can use the very actually the real-time services like as the telemedicine or something for some industry needs to actually more accuracy. The peak data rate is at least 1 terabit per second. And about the actually the rate user rate you can see here the user rate gigabit per second mentioned that gigabit per second in this picture. Actually, and another slide I can explain more about that. This all KPIs compare 5G and 6G together. Just only you know about that this the which KPIs is very important for IMT 2030 because this is the IMT use IMT 2020 that one, and we expected the IMT 2013 maybe actually we can accept it this one and for data peak rate is at least 1 terabit per second, and actually for huge capacity and support high mobility, reduce energy data reach 10 data rate reach 10 gigabit per second, 10 times 5G. Yes, actually, I did practically a lot of tests in the lab and in the field about the gathering all actually the maximum achieving to maximum throughput from for 5G advanced. Right now we are working for enable the services features and by our vendors providing the new features to enable us to achieving to target and to maximum target, but still in the we are in the actually in the road for achieving to a maximum rate, and this is just only theoretically, not practically. And you cannot, for example, if you hear about the 6G or 5G advanced, you imagine by the clicking you can download, for example, one movie less than, for example, less than 1 second. And in the practically maybe not happen right now, but for future, yes, we can expect it about this speed. For spectrum efficiency, 5 or 10 times more than 5G. And for high 3D coverage extension, including terrestrial, aerial, and space. We can talk about more about these KPIs. You can see this picture. This picture is showed about that the integrated ground, sea, air, space in the 6G. As you can see in this area, the ground sea network is here, and all of the elements that you can see here are items can communicate with the other layers. This is very important because the air network, a space network, even a space network, and you can communicate all others layers together, and all you can see there, for example. This one can communicate with the antenna, and the antenna can communicate with the center with the drone. And for example, the two of items we communicate together. And you can see, for example, this drone, okay, communicate with the satellite, drone, antenna, and after that, after the communication, we can communicate as, for example, this satellite can communicate with this satellite, and after that, with all of the items, we can communicate together with the all areas. This is in this 6G, we expected we can communicate more easier. And what's a new scenario in 6G beyond in 2030 after we actually we see the first time the 6G in 2013, we expected about the smart production, a smart life, a smart society. Right now, we are using the Industry 4, and on that day, we expected about the Industry 5. Industry 5 means, for example, a smart production, intelligent agriculture, by production, simulation, balancing of supply and demands, and also intelligence industry, include digital wars, nanorobots, collaborative self-driving production. And this is in the side of the smart production. And for a smart life, twin body area network, monitoring of vital sign, nanorobots or therapy. And so for a smart society like as a social government and public transportation services providing for here. And so we can see in the 6G and actually all of them provided a better life for us. All of them providing the a smart transportation, a smart production, a smart life, and then we can getting better services and better life in with this 6G and beyond. And I promise you for about the compare 5G and 6G use cases. Yes. As you can see, I don't know, this is a little bit small, I think, for you. Hopefully you can see this one. Actually, I want to quick review. I don't want to read all of them. I want to quick review and then for another slide. So for data rate in 5G, as you can see, for 1 to 10 gigabit per second. Actually, the use case of this speed is telemedicine. The telemedicine, you know about that, the doctor communicate with the patient and maybe needs some information of patient. And this data rate is good for telemedicine, for example. For 6G, we expected for 100 gigabit per second to 1 terabyte per second. Okay, this is a very good speed for right now. We compare with the current speed, but still, I think this is the theoretically, and in the practice, maybe a little bit less than this number. And the use case is 3D holographic, AR, VR, and robotics arms for these use cases of for 6G. And for coverage extension, yes, this is the millimeter wave sites, and this is why in less than 1 kilometer. Yes, the point 0.1 kilometer, 100 meter, for example, is limited for you. The use case is a limited scale of IoT network. Okay, but for 6G, we need 3D coverage scenario. 3G coverage scenario as from the sky to ground, we need to communication. And so the coverage should be 3D coverage, yes. And so, for example, I actually, I mentioned that here, you can support, imagine the coverage from the up and up to down, okay? And need the coverage all of area. And so for the terrestrial, aerial, space, and sea domain, massive scale IoT network, we use in this one. For power consumption, yes, power consumption, we expected for devices that with the 10 years battery life, IoT devices, and for 6G is 5 times improvement compared to 5G we expected. And for which devices, what is the use case? The use case is variable user devices with the zero energy devices. What does mean zero energy devices? The zero energy devices is the devices without any battery. And please suppose you have IoT devices, no battery, and can communicate with network. How to do that? By the frequency, actually the devices can be charged and then get a power and communicate with the other devices. And so there is no need to any actually the external energy for communicating with the devices. And so this is the zero energy devices as well. And for end-to-end latency, you can see in the 6G, less than 1 millisecond for healthcare network, AR and VR. And for 5G, you can see between 1 to 5 millisecond vehicular, sorry, vehicular networks and military services happen for the as a use case we can expect it for this area. And so, as you can see, reliability communication is more accurate. The same actually use cases and telemedicine and healthcare network AR and VR. And this is the drone, unmanned aerial vehicle, UAV, robotics arms. And all of them actually, you can see the accuracy is very, very near to 100%, but still not 100%, very, very near. And so reliable communication means we can trust the network. We can trust the network for some sensitive industry, for some sensitive, for example, for autonomous car driving by autonomous systems, the car they are driving by the autonomous systems. But if you suppose, for example, the network cuts, okay, what happened after that? Maybe accident happen, okay? And the reliable communication ensure that we can trust the network to actually communicate every time, every time with no losing connection. And so massive connectivity and sensing, you can see is in this for 5G, 1 million devices, and for 6G is 10 million devices. And yes, we discussed about the variable user devices and IoE. IoE means everything of, Internet of everything's. And so actually we can expect it for 10 million devices per square kilometers. For actually for frequency, we discussed about that in previous slides, and for mobility and speed, uh, yes, this one you can see 500 kilometer per hour for cars, but for 6G we can use with the speed of 1,000 kilometer per hour. What does mean? These mean we can use in the airplane, in the sea, in the space, in the terrestrial. And so this is the benefit of the 6G. Okay, um, this is the actually a very good actually explanation of the unmounted aerial vehicle system in 6G. What happened for what happened in this 6G for UAV. As you can see, we have three layer. Layer one, this area, yes. Uh, Smart city, end user devices, vehicular network, and home, for example, home to hospital service. Okay. And all of them covered by the, actually, you can see by the UAV. UAV works here in the low altitude for network. Okay, you suppose about two layers available, high and low, and some of them works in the low altitude, some of them works on the high altitudes. Okay. And so you can see in the smart city, we use the drone, and the drone connect to tower, 6G tower, and the end user can connect to the 6G tower. And please attend for this car. This car, it can directly connect to this drone, not connected to tower. Okay, connected to drone, and this drone connected to um, um, for example, one UE, or one actually another point, and so communicate with the satellite, and there is no any connection between this car and the 6G tower. And so this is a benefit of the using of UAV system in 6G, providing the connectivity for many devices in for upper layer and actually in the lower layer. And so you can see this, you can see this drone, all of them, and can help us to communicate all um, items together. So for another example of 6G actually use cases about e-health. E-health is very important for all countries. You can see in this you can see here, for example, for actually for we have three layers: the physical layers and big data layers here. The physical layers, this is the remote doctors from the, for example, your country or another country can communicate together or with the patients, or and collect the data here, and healthcare monitoring systems, and medical IoT, and hospital to home services. And this is the physical layer, and gathering all information here. For example, this patient actually the provide the information of the actually the survival, actually the parameters, all parameters, and know about that. We want to know about that. The second layer about that access, intelligent access layer. This layer include physical layer and big data layer. By means is intelligent sensing layer. Sensing layer is very important for actually for gathering all information based on the sensors and have in this layer. We want to provide to all information to upper layer. Upper layer is access layer. Access layer providing by the millimeter wave and terahertz, by millimeter wave and terahertz. Yes. And so by drone, by tower, and we can actually communicate with the all devices here and getting all information, and then deliver to upper layer for it means the intelligent cloud layer. And this area has the intelligent patient monitoring systems. The end user, for end user, I means, for example, anybody wants to monitoring all information from coming from here can access to this information for providing better services for this area. By edge computing, AI, and machine learning in the SDN network, NFV network, mobile edge computing, and so we have a lot of centers for computing the all data, and then providing, for example, a dashboard and show the all information from the actually the patients or hospitals. This is one example of use cases we can use in 6G technologies. And another example is actually actually about the IoT industrial. For a smart factory, we actually we have a three layers. Like as the previous slide, we have three layers: physical layers, access layers, cloud network. And for each scenario, we can define which items should be as a physical network. Here is IoT industrial IoT, or IIoT, and digital data sensing, and big data for example, for a smart factory, for a smart factory, for example, the car factory, or something like that. The big data providing here by the sensors and delivered by millimeter wave to access layer. You can see the delivered by millimeter wave to access layer. In the access layer, by the tower or millimeter wave or drone, we can access to other upper layer for cloud services, for supervision the network. What happened in manufacture happen. For example, we can track one small screw lost in the production. Yes, we can see all of the production line, even one screw. And so we can monitor all of things and getting better services, and then as a result, better actually product for customers. And another thing, the connected autonomous vehicle systems. You can see here uh, at this picture, you can see the cars, okay? And the cars are connected to actually through the 6G technology. We discussed in the previous slides about terahertz, millimeter wave, edge computing, and AI ML. We discussed about that the three layers can help us to, yes. And this is the K technology. It help us to, we have connected autonomous vehicle systems. As you can see here, we have a car, and that car communicate together. Vehicle to vehicle can connect together, and the vehicle can connect to drones, and the drones connect to a tower by the terahertz, and to internet and mobile computing. But what the functionality for the actually for transport control systems, sensing, communication, computation, and positioning. All of this information is important for the controlling the car, and car cannot have accidents. And so for what requirements for this actually for ecosystems? Extremely low latency, we discussed about that. Ultra high reliability, and we discuss again, and massive connectivity. Massive connectivity means we want to more connection together, and high throughput. The high throughput is very important for communicate in the with the highest speed with the the car, and actually the data processing, because based on the camera mounted on the actually windshield of the windshield, the processing of the data by the cloud, it needs to high throughput to make decision for cars, for yes, for actually for getting better services for driving. Yes, and this is why we need to actually the 6G for next generation of driving. Due to a time limitation, please let me, if my time is exceeded, sorry. We have actually, I talked actually more than the time. If the time is over, please let me know. I stop. For 6G requirement and capability, I just only for a picture, we can see a screenshot of the requirements again. In the 6G, we have 8 requirement and capability. You can see the new promising application, new computing fabric, new actually a new computing fabric, and network flexibility, and enhanced connectivity, trustworthy application, and high coverage, diversity of embedded services, and cognitive networks. This is the 6G requirement for and capability. And so I want to explain about the enabling 6G enabling technology. For 6G enabling, you can see the terahertz communication. We discussed about that. The holographic beamforming, we in the next slide, we can discuss about self-free massive MIMO, artificial intelligence, blockchain, and zero energy interface, and quantum communication, edge intelligence, intelligence reflecting surface, and we can discuss about more, and new multiple access techniques, and new coding techniques. This is the all enabling technologies. This is the based on the research. Maybe you can find a new article and little bit different, and or adding more items. And so this is the research, and not a standards, but by the general and the scientists research about that the 6G provided the 11 enabling key enabling technology. For holographic, I promised to you number 2, you can or holographic, yes. The holographic beamforming, it means the all actually you can see the all of them communicate with the you can communicate with the tower, with the actually new technology, holographic beamforming as a with very, very low cost compared with the other technology, for example, the MIMO, and very actually, they actually they can or I mean for example the manufacturer or RF engineers by the software can actually by the setting for the direction of the between the sending information and getting information for nodes can be defined and is very, very accurate. And with the new technology, the holographic, and so they can communicate the back of antenna. We can back of antenna equipped with the holographic beamforming equipment, and so communicate with the, all of them. And this is actually the new solution for reducing the cost and providing better services compared with the MIMO. And this is the self-free MIMO due to time limitation. Sorry, I want just only for quick reviewing about that. As you can see in the self-free massive MIMO, the user can connect it to the one of them, and all of them is can connect together. And this is actually very affordable in the network. This is the central processor for processing the data, and compared with the MIMO, has more benefit for actually for providing the services for end user. And for IRS is actually this is very, very interested technology for providing the actually the coverage for user. Please attend this user. This user not connected to antenna. Just only the car connected this counter, the car connected to tower, drone connected, but actually you can see all of the red arrow showing the reflected signals. This antenna is like as a, for example, you can mount it on the wall. Yes, and actually you can see the here all of these items can reflect it to antenna. This antenna provided the service for end user through the reflected from here and here and here and connect all of them together. And this is the IRS, and this is the intelligent reflecting surface. And the cost is very low, installation very easy, and actually vendors and operators try to use this technology for instead of installation new sites. This technology is very interested for 6G. And so please let me explain about the 6G architectural vision. Again, connected intelligent network, integration of AI and ML, network sensing, full coverage connectivity, integration of terrestrial and non-terrestrial network, trustworthiness, and sustainable development for next generation of mobile considered. And what the challenge? What's the challenge? Yes, the device capability, terahertz spans, network security. These are three main challenge. The device what does mean the device capability? The device capability means currently the devices not ready for connection for connected to next generation. There is no any standards. There is no any release of 3GPP to order, for example, to manufacture, to providing the new handset for 6G. And there is no any standard yet. And actually the devices should be works in the higher band frequency Actually, there is no any devices right now, and should be providing by the manufacturer through the 3GPP standard. And for terahertz bands, yes, terahertz band is very important for 6G. As we discussed, the terahertz band before previous use in the satellite, and we want to come down to cellular, actually bring to cellular communication terahertz, and there is no any regulation. There is no any semiconductor, for example, uh, mobile devices cannot work with the terahertz bands. There is no any circuit where it can work in the mobile works for terahertz bands. And so this is another challenge for after the regulation for cellular networks confirm, and actually the manufacturer know about the 3GPP, and then it starts happen for actually the devices can works with terahertz bands. And for network security, for each generation of mobile network, the network security is the most important challenge, and not only for 6G, for 5G, for 4G. The network security for 6G as well is very important because we have a lot of actually 10 million devices we want in per square per kilometer want to connect to network, and we want to all applications secure, all connections secure, and there is no and the firewall and in the core network. And so right now, due to complexity of the network and no any standardization right now, the network security is another challenge for how can provide the network security right now, because there is no any actually standards, and we don't know about that what happened in 2013 in 3GPP, and then what's the finalized network architecture. So after that, we can expect about the network, how to provide the network security. security. Yes, thank you so much for all of you and for listening me. And sorry about that if I talk more about that at the time. And thank you again for all students. I am here for if you have any question, please let me know. And I have just only I want after if you don't have any question, I can just only for minutes for career opportunities I want to for telecom sector. Thank you so much.
Thank you, sir. Thank you so much. Now I would like to say a vote of thanks by Raghu.
Hello. So, good morning, sir. Sir, am I audible, sir?
Yes, good morning.
Sir. So, actually, sir, how can we do research in orthogonal time frequency space modulation through VLSI, sir?
Uh, Sorry, can you repeat again or send me a question because I can
Sir,
hear clearly.
sir,
Can you
OTFS, sir. OTFS, orthogonal time frequency space modulation.
sorry?
OTFS, sir. Orthogonal time frequency space modulation. So, Alex, can you please tell me, sir, how we can do research in wireless communication through VLSI? Is that possible, sir?
Sorry, I can't hear you clearly. Could you please send message by the chat?
Aha.
Sorry.
Yes, sir. Yes, sir. I'm typing, sir. Yes, sir. I'm typing, sir. Sir, please check the chat box, sir.
Okay, yes, I got your point. Sorry. Yes. Actually, in as you know, in VLSI, a very large scale integrated systems using for all industry, all industry, especially the vendors, for example, Nokia, Huawei, and some hardware production using the VLSI for a new generation of the actually the devices or equipment for radio frequency or edge computing in the core systems. And so the VLSI um, actually you can in based on my experiences because I am a hardware engineer and before that I have a project for VLSI as well, and for after that in mobile communication actually there is no for example experience about the VLSI directly for user, for example, for end user, for just only for research, just only for research. Uh, you focus, I think, you focus on the hardware of the, for example, radio part or core part, and you can research about the, for example, the new systems for example, for Open RAN. Open RAN is new systems and how to work inside the, for example, the hardware of the Open RAN. And so for new generation, equipment generation for the, as well for core, the part of the core, all of the routers and systems and or new systems works based on the VLSI systems. And so if you have any, yes, okay. Yes, this is based on the actually you can for wireless communication. Yes, you can use for any modulation for actually for different type of for example project we can you can use for all of them, but for example for 2G, 3G, 4G, 5G and 6G, actually, we need to very specific project. For example, Nokia every year or Ericsson every year published a new project for example, for OTFS or something like modulation for new modulation, and maybe needs to using the VLSI. And you can find and contact with the R&D of the vendor with the vendors and can communicate with them through email, and I can help you to connect R&D if you want. I can connect to you for example do R&D for some operators as I know, and you can see in the LinkedIn some people work on R&D and you can get some advice about your project.
Okay, sir. So, how high throughput can be managed in a high vehicular network, sir? So because the main criteria for any vehicular mobility of network is high throughput, sir, what is the main challenge in that to achieve high throughput?
Yes, the high throughput is one of the main actually challenge for autonomous car, because you know for example, the car has the camera, and camera works as the eye, and and should be process all of the information coming from the camera. Okay, but
Yes, sir.
which system what the decision for which system what the decision the computer inside the car, or mobile computing outside of the car on the cloud. If the computing run on the cloud, okay, we should have a highest throughput for communicate the car, and the cloud center for communicate all of them. Because if there are a little, for example, the low throughput happen, okay, the decision for the car for turn right or turn left, maybe, for example, we get with the delay, and something happen for accident. And so this is very dangerous for car. And so we should guarantee, actually we have a guarantee minimum throughput. For example, minimum throughput, I means the highest we can achieve. And then we should try to use for communicate with the cloud center for processing the image processing. And yes, this is why for using high throughput for CAV.
Okay, sir. Thank you, sir. Sir, can
Thank
we
you.
have any query regarding this kind of wireless communication related? Can we mail you, sir, regarding any doubts?
Thank you. Just only I want to talk about just only for career opportunity in telecom section, just only for 5 minutes. For a graduate students wants to work in this section. Um, Actually, as you know, the telecommunication sector has a lot of actually actually the opportunity for career for graduating. If you want to join the if you want to work as a telecom engineer or wireless telecom engineer, we want to work to you mentioned you want to consider about that uh, the RF engineering, core engineering, data scientist, and so actually security scientist or engineer, cyber security, I mean cybersecurity. And so all IT, as all of them are people educated in IT section and actually telecom section, have a lot of opportunity for working in this industry, for especially for 5G explode for a lot of carrier all around the world. And so you want to monitor the opportunity and find the requirement, which requirement for each uh, section needs require, for example, for mobile, actually, as I actually experience about the radio frequency, I focus on the actually the quality of experience and quality of services, and needs the knowledge of the data scientists and radio frequency, and actually how to work with, and actually how to troubleshooting and root cause analysis needs to actually for this position. And for right now in Canada, as I know, a lot of for after the 5G launch, all operators called many people or many graduate students for joining to expanding the 5G networks or swapping the 4G to 5G. and it still continue. And I think for all other countries, the same is the same. And if you want to work as a mobile, actually mobile communication engineer, you can just only see actually their websites, for example, Nokia, Huawei, Ericsson as a vendors uh, or operators. You can find the opportunity as you can for apply for them. If you have any question, if you want to know about that 6G, if I can, I have other information. I'm so happy to share with you. And thank you again for organizer and for all students listening me today. I'm really appreciate of all of you. And I hope we can have a meeting next for next time. Thank you so much.
Thank you so much, sir. Thank you.
Thank you, sir. Thank you so much. Now, I would like Raghavi to conclude the webinar.
Thank you, sir. I deem it a great honor and privilege to propose the vote of thanks. First and foremost, I would like to thank my Alvizade sir on sharing his views and knowledge regarding 6G. I would like to thank RIT IEEE Student Branch and Department of ECE Vice Principal Dr. P. Satish Ram Chaudhary sir and Student Branch Counselor Dr. VSS Chakravarti sir for attending this webinar and showing their enthusiastic support. A special thanks to organizing committee, teaching staff and non-teaching staff for their unflinching support and coordination. Our heartfelt thanks to our students for active participation in the webinar and making it a huge success. Thank you, sir. Thank you so much.
Thank you and goodbye.